In this presentation, we're going to talk about restricting domains. And again, don't stop the video. This should look similar to what you already previewed when we were finding inverses. But we're just going to go ahead and take a step forward and actually find out, how we'd have to restrict the domain to make sure that the inverse still remains being a function. So this is all the work that we did in our previous video, where we were actually taking the function, we rewrote the function in vertex form, and then we actually found the inverse function. If you haven't watched that video, please stop now, go back and rewatch that video presentation before moving forward. But now our direction sheet's going to change a little bit. Rather than finding the inverse, what we're going to do is we're going to find what the restricted domain would have to be, so that way the inverse is a function. So let's go ahead and take a look, and again, let's start off with the function itself. And the function itself is x minus 4 quantity squared minus 6, because remember, we rewrote that using the vertex form. And what I have done is I've gone ahead and I've graphed that particular function for us. And one of the things that we remember is that if I have a graph, I can actually come up with its inverse by going ahead and taking all the points and just switching the x and y and plotting those points. So if I were to do that, let's start off with the blue. I would see that the inverse would have a point at negative 6, 1, 2, 3, 4, 5, 6, positive 4, 1, 2, 3, 4. Right there's a point, and this is at negative 6, 4. I could also have another point at 5, negative 5. I'm sorry, negative 5, 5. So negative 5, 5 takes me to here. And I have another point at negative 2, 6. Negative 2, 6 takes me to here. And I'm just going to start off by focusing purely just on the blue. And here's the reason. Is if I go back and I start thinking about functions in general, I remember that there's a thing called the vertical line test. And the vertical line test tests to see if a given graph or relation is actually a function. And as we view this right now, we can see that this graph passes our vertical line test, because all those vertical lines only intersect the graph or the function in one place. I further would see that if I would go on and I would start plotting these additional green points, if I were to plot the point negative 5, 3, negative 5, 3 gives me a point, right there. And now what we would see is that would actually fail the vertical line test. So that's where we come into this point of going ahead and restricting our domains. We're going to restrict our domains so that way our inverse is actually a function. Now, how's that actually going to take place? Well, what has to happen is we could go ahead and take a look that in order for this blue graph to occur, what we are going to do is we're going to go back to our original. Here's our original graph. And we look at what is referred to again as the axis of symmetry. And obviously the axis of symmetry is passing through our vertex. So this blue graph is formed from a domain that would be from our value of 4 going to positive infinity. So as long as we were substituting in x values from 4 to positive infinity, we're getting this blue inverse graph. So the restricted domain, in order to get this, would be from 4 to negative infinity. Now on the flip side, if I wanted to get the green graph, I would have to go from negative infinity to negative 4 to get the green graph. And the green graph would look like as follows. We would have that point here, and we would have our point at negative 2, 2, right there. And here's our green graph. And if we go back to what our actual inverses are, if we go back to our inverses, what we calculated, you could see that we had the following. We had the inverse is 4 plus or minus square root of x plus 6. So what this is saying is, if I'm restricting my domain and I want this top version, 4 plus the square root of x plus 6, well, we said that would have a domain that would be from 4 to infinity. However, if I wanted the bottom portion, or let's actually put the green version, which was 4 minus the square root of x plus 6, then our domain is going to go from negative infinity to negative 4. And that's all derived basically from our vertex form from our original function, because that dictates what happens in our inverse function.